I wanted to go over some covalent bonding examples with you before you started your work for today. So I'm going to go ahead and get started. So by now you should have already watched the video lesson on covalent bonding and you should be getting ready to start today's assignment. So the first thing that I want to do is bond together carbon and oxygen. Okay, so the first thing that I'm going to do is make sure that both of these are nonmetals because I cannot make a covalent bond unless I have two nonmetals. Carbon is a nonmetal, oxygen is a nonmetal, so these two elements will make a covalent bond. The next thing that I'm going to do is make Lewis dot structures for each element. So carbon's symbol is C. On our periodic table, carbon is in group 14, which means that it will have 4 valence electrons. Oxygen is O, and oxygen has 6 valence electrons. So 1, 2, 3, 4, 5, and 6. So the first thing that I want to take note of are my electrons that are already paired together. So these 2 electrons are paired, so they're good. These 2 electrons are paired, so they're good. So on this atom of oxygen, I have 2 electrons that are unpaired. On carbon, all of the electrons are unpaired. So all of those 4, each of those 4 electrons are going to have to make a bond with another electron. So right away, I can go ahead and create 2 single bonds with oxygen. So I'm going to do that by drawing lines from carbon's electrons over to oxygen's electrons. So I'm going to draw a bond here. So now those 2 electrons are being shared between carbon and oxygen. And I'm going to draw a bond here. So those 2 electrons are being shared between carbon and oxygen. Next thing I'm going to do is count by number of valence electrons that oxygen now has. So it has 2, 4, 5, 6, 7, 8. So oxygen has 8 valence electrons, and that's all that it wanted, and that's all that it can fit in its outer shell. So this atom of oxygen is full. But carbon still has 2 electrons that are unpaired. So what we're going to do to fix that is bring in a second oxygen atom. I'm going to draw it down here. Then I'm going to put the valence electrons for oxygen around the symbol. Again, oxygen has 6 valence electrons. So I've got 1, 2, 3, 4, 5, and 6. Oxygen has a pair of electrons here and a pair of electrons there. So they're already paired together, so they're good to go. And then 2 unpaired, which works perfectly for the other 2 for carbon that are unpaired. So then you would just draw bonds to connect carbon's 2 unpaired electrons with oxygen's 2 unpaired electrons. This looks pretty crazy, so we're going to clean this up. So we always have a central atom. In this case, our central atom is going to be carbon. So we're going to put that in the center. And then we're going to draw a double bond to oxygen and another double bond to oxygen. That represents the bond here to this oxygen atom and the bond here to this oxygen atom. Then we're going to count and make sure that we have our correct number of valence electrons for all 3 of the atoms in this compound. So remembering from the video lesson that each line, each bond holds 2 shared electrons. So 1, 2 are located here, 2 are located here, 2, and 2. So I'm going to check carbon first and make sure that it has 8 valence electrons. It has 2, 4, 6, and 8. So carbon is good. I'm also going to take from oxygen over here and place those pairs of electrons that were already paired up together in my new model. And then I'm going to make sure that each oxygen atom has 8 valence electrons. So we're going to start over here. 2, 4, 6, and 8. So this oxygen atom has 8. It's good to go. 2, 4, 6, and 8. So all 3 of the atoms in this compound have 8 valence electrons. Even though that those are shared, we count them as carbon's valence electrons as well as oxygen's valence electrons because they are sharing those. Then the way that I would write the formula for this, I'm going to put carbon first because it's our central atom. The central atom always goes first in the chemical formula. I have one carbon atom. Our subscripts tell us how many of each atom we have in a compound. So I have one carbon atom followed by oxygen, and I have two of those. Now, most of the time, you're not going to see the one represented. The one is understood. So if you were to see this on a test or in a textbook, it would be written CO2. That tells me that there's one carbon atom and two oxygen atoms in that compound. Let's try another example. Let's try to bond together. Let's do nitrogen and fluorine. So I'm going to write the names out first. Nitrogen and fluorine. All right. So nitrogen has 5 valence electrons. So I'm going to draw its Lewis dot diagram first. 1, 2, 3, 4. And I'm going to put this one over on this side. Fluorine has 7 valence electrons. So 1, 2, 3, 4, 5, 6, and 7. So the first thing I'm going to do is circle my pairs. So nitrogen has 1 pair. So those are good to go. We can't mess with those electrons. Fluorine has a pair here, and a pair there. So fluorine is left with 1 unpaired electron, while nitrogen is left with 3 unpaired electrons. So what fluorine can do first is make a bond with 1 of nitrogen's unpaired electrons. So that's 1 single bond. There are 2 other nitrogen electrons that need a partner because electrons like to be paired together. So we're going to have to bring in a second fluorine atom. 1, 2, 3, 4, 5, 6, 7. It has 1 unpaired electron that can bond with nitrogen. Nitrogen still has another unpaired electron, so we'll bring in a third fluorine atom with 1 unpaired electron, and that will make a bond. All right, so next we're going to check and make sure that all of our atoms for this compound have 8 valence electrons because that is their goal. We're going to start with nitrogen because that's our central atom. So it has 2, 3, 4, 5, 6, 7, 8. So nitrogen's good. This fluorine atom down here has 2, 4, 6, and that makes 8 because there's 2 electrons in this bond. Fluorine atom here, 2, 4, 6, 8, and our third one, 2, 4, 6, 8. So all of our atoms in this compound have 8 valence electrons, which means they are very happy. Now let's clean this up. So our central atom is going to be nitrogen. I'm going to place nitrogen's pair of electrons on the symbol, and then I'm going to situate the fluorine bonds around. So fluorine, fluorine, fluorine. So when we clean it up, we want to make it nice and symmetrical. And then you can add in fluorine's loose electrons. When I say loose, I mean that means they're not in bonds, they're not being shared with nitrogen. And then remembering still that there are 2 electrons that are being shared in every bond. Now we're going to write the formula. So we always start our formula with the central atom, which is nitrogen. We have 1 of them, but like I said on the previous problem, the 1 is understood. And then we have fluorine atoms. We have 1, 2, 3. So our subscript will be 3. And that is your formula when you make a covalent bond with nitrogen and fluorine. We're going to do one more. Let's try sulfur. So we're going to make a bond between 2 sulfur atoms. Sulfur. So nonmetals can bond with each other. So like a sulfur atom can bond with another sulfur atom. So we're going to see what that looks like. So the first thing I'm going to do is draw my Lewis dot structure for sulfur. Sulfur is in group 16. So it does have 6 valence electrons. And I'm going to draw another sulfur atom, which also has 6 valence electrons. So we're going to circle the pairs. So those electrons are good to go because they have a partner. And then on each sulfur atom, there are 2 unpaired electrons. So this electron is going to partner with the electron on the other atom of sulfur. And same down here. So sulfur actually ends up creating a double bond when it bonds with another sulfur atom. There are a total of 4 shared electrons here because there's 1, 2 in the first one, 3, 4 in the second one, and we actually call this a double bond. The way that we would write the formula for this would be S, and there are 2 of them, so S2. All right, I hope that helps. Again, if you need anything or if you have any questions, feel free to message me. Good luck.